this activity, what I'm going to show you how to do is actually to get in and work with circuits using TinkerCAD. Because we're virtual right now and I can't bring to you a series of circuits like this and let you be able to experiment with them with me, then you guys kind of get to take the role of NASA, some engineers trying to help me figure things out, okay? So what you see here is I have three different LEDs. I have a green one, a blue one, and a red one. And I have them actually mounted in a breadboard, which you see right here, with a series of circuits. You see when I turn on, I flip the switch for my power right here. So when I flip that switch, you see that the lights turn on and off. And what's super cool about this one is I do have this actually done in a parallel circuit. And what I mean by parallel is that each LED is receiving current directly from our battery pack, rather than if I had these in a series circuit, okay, where each one would be drawing its power from the next. Because I have these in parallel, just because one of my lights is not working, okay, it doesn't make all the rest of my lights cut off. At our last camp, we showed you guys how to access TinkerCAD, okay, and what I'm about to show you right now, I'm going to share my screen with you and share with you that through TinkerCAD, you also have the ability to be able to work with different circuits. So let me get my screen up. All right, so what you're going to want to do for this activity is actually get into TinkerCAD. Okay, so you go to tinkercad.com, and from tinkercad.com, you want to create your own account if you haven't done so already. Work with your family on how you want to create that account. It is free, but you need to figure out like what your username is going to be, what your password is going to be. And that really is something that needs to be discussed with your family when you're setting that up. And you see right on here where I can click on 3D designs. Okay, so if I want to make a CAD design, I can just come over here to create new design and it'll pull up a TinkerCAD platform for me to be able to make a new CAD design in. But today I want to work with circuits. So if I go over here to circuits and then I'm gonna say, all right, let's create a new circuit, okay? So you're gonna see this pop up right here. All right, so I want to, in getting started, first I have to have something that I'm gonna put my LEDs in. So right over here on the side, I have the ability to move this toggle back and forth so I can find different items. So this is a click and grab, which is good. This is a small breadboard. All right, so I have my breadboard that I will connect things to. And now bring in an LED. So here you see I have my LED that I brought in. You see that's cathode. I would toggle over here, that's anode. Anode is where I'm going to give it the positive connection of my power in just a little bit. So this one right here, see I had red as my first one, so I'm going to put this one over here. All right, so I'm going to start with a red one. Now, because LEDs do not have resistors built in, we actually have to place a resistor in front. And you see, so I brought that over. And you see with this resistor, it shows a resistance of 1 here. Let's make it 110. Okay, so this little, what looks like a horseshoe over here is the symbol for ohms, and that's telling us what our resistance is. I also need some power. How about, let's get a 9 volts, which is what I was running earlier. Now, with my 9-volt battery, see if I toggle over here, it's telling you, okay, this is my positive connection. Power that I get out of here, I'm gonna take, and you saw where that turned up as red, I'm gonna put it actually on this rail right here. This is my positive rail. When I click on it, you see it lights up. Now, I like to make my positive wires just for my own preference to organize it. I like to make mine red to help me keep organized which wire goes where. So now you see I'm pulling it over again, and now that's my negative rail. So I'm going to make that one black. Okay, now to move this, all I have to do, say I want to move it into a different pin, just click on it again and I can take and move it closer. Now, because I put my positive and my negative wire for my battery into these rails, that means each one of these little dots now actually would have a positive charge. So I'm going to take this one and extend a wire, make that one red again. Okay, so coming from here, I brought a red wire over to my resistor, almost as though the red wire and my resistor kind of holding hands under the scenes here, right here. But really what's happening is that it's taking and transferring a flow of electrons. Now I have my positive flow going in. It's going to go to where the anode is. See how this LED has this crooked leg? Okay, so with that crooked leg over there, that's where our positive charge is going to go in at. So that's my anode. Okay, so now I need a place for my negative wire to complete my circuit. Okay, and we're going to make that black. So you can think of it as like spent electrons. That's not quite what it is. Right? So I've completed a circuit. My power has gone in. I was able to take my power, I transfer it through the resistor to the LED, and then to complete the circuit, because we have to have that complete flow of electrons all the way through, it goes back now to the negative rail, transfers here, and goes back to my battery. So when I come over here to where it says start simulation, let's see if I can light up my LED. All right, and you may have noticed the LED got a little bit brighter. You can tell when I turn it on and off. Now, what if I'd like it to make it a little bit brighter than that? So let's reduce my resistance. Let's see if I make my resistance, what if I made my resistance 50? Let's see what the difference would be. Now you can see a little bit of a brighter, see with that one there with the red? What if we even took it lower? Now you can't make it 0 because actually it won't light up. And if you had an actual LED, you were doing this and truly trying to pass electrons through it, not just simulating it, you would actually bust your LED. So see with a 10 resistor, okay, you see that LED light is even stronger. Okay, so now if I wanted to make a parallel, I'm going to take this and shorten my wire just a little bit. All right, but if I was going to make a parallel, I can bring in another. Oh, instead of having them both red, let's change the color. So I'm going to make mine blue. And I'll give myself another resistor. We're lining that up with the anode side. I'll also give it a resistance of 10. Now, if we're going to make this a parallel circuit, that means we'll bring this one over from power. We'll make that one red. Okay, and then we'll also take, and we also have to ground this one, which is another thing you might hear this called. So we're going to ground it. We're going to complete our circuit and make this one black. So now what you see here is when I start the simulation, you're going to have a flow of electrons that go this way and a flow of electrons that go this way too. They call it parallel in that way because these two don't have to interact with each other. Right, so let's see what that looks like. Okay, so now you can see they both turn on. All right, now the other type of a circuit that I can make as well happens to be a circuit that is in series with each other. So you see this is kind of the return trip of our electrons, right, coming back. Now, because I got rid of this one, if I were to simulate this, you'll see only my red one comes on because there's now no electrons going to the blue LED. But if I put them in series with each other, so I can do that by bringing this one over. Now remember, I had this as black, but this can be any wire. I'm gonna make this red, okay? The reason why I am is because it's showing, okay, it's coming in from my 9-volt battery. I'm making my way over here, right? The electrons come to the red LED and the electrons continue to go through. Now they hook into the blue LED and then they make that return trip this way back to my 9-volt battery. So let's simulate this again. And if you notice, the lights are just a little bit dimmer. So now instead of each one getting their own, okay, now they're actually sharing the flow of electrons. Okay, so here, if I change, let's make this one, oh, not 1010, let's make it 110. Okay, and this one over here, I'm not going to change at all. So you would think that it would still be just as bright, but since these are in series, they both still keep the same resistance. So the resistance here is actually added to that one. So it makes them both dimmer. So if I made this one 110 too, let's see if it makes difference just slightly. All right, so this actually can be a lot of fun to where you can work with these and see different ways that you can connect, okay, with different wires. I like using these and being able to work with different configurations for wiring. There's also a programming side to this too, but we're actually not going to get into the programming aspect on this video. And that's where some of these other pieces come into play, like with the push button, the potentiometer, some of these different switches and things like that, the Arduino. If that was something I were to pull out, okay, I could actually, instead of wiring it to the 9-volt battery, I could wire it here to different either digital or analog ports, depending on what I'm working with, onto my Arduino. But then I'm going to want to actually program it to be able to get it to work. And that's something that we would definitely have to share in an entirely different video. But to, but to give you guys a chance just to be able to work through and practice and play around just with circuits, I wanted just to show you just a basic component of how to set up different circuits in that way. All right. Okay. So I know it, this is kind of a bigger activity. So definitely as you get to it and work through it, if you have any questions at all, do not hesitate to ask your family if they can help you email us, or when we're on one of our mission control calls this week, definitely ask us any questions that you might have about working through this, okay? Best of luck as you guys do this. I'm hoping at some point I get to physically sit down and face-to-face we can work with some Arduinos and stuff like that, because not just working with the LEDs, there's all kinds of fun stuff that we can make, thermostats and different things where we can get our muscles to actually control movements through our Arduino. We've got a lot of different really cool sensors and things that we work with through at Hammond High that I know we'd love to show you guys sometime.